Uh, Hello everyone. Today I'm presenting NAD and SEM question paper solution. This is question paper overall, and and, and the solution is first of that. The first question is give a non-linear equation of f of x. Apply various numerical method to find its roots. For any one of numerical method, bisection method, perform the following task. So, so this following task, okay, this question. So first of all, I'll go. Start. Define the function. Function we define with this equation and input the interval a comma b such that this equation input the tolerance error limit repeat until the error is less than e. E means 0. Find the mid which a plus b by 2 and f of mid. If f of mid is equal to 0, then the root is found and return the mid. Else, f of a is multiplied by f of mid less than 0, then b is equal to mid and else of a is equal to mid. Print the mid as root approximately and stop and end of algo. The flowchart is that start, did A, B, E, then while loop which are we applying, which are true so that the going the mid is equal to A plus B by 2, then another if condition which are satisfied, then we directly print the root and not satisfied, we got this another condition that's true, so B is equal to mid and this not true is A is equal to mid. Something going on. If this while loop is false, then we going to this equation. We going to this. Okay. And then the algo error and cov- uh, coverage analysis. The error at each step is b minus a is by 2, and the iteration increase the error half is show linear coverage. Bisection method was order coverage is equal to and show but guarded coverage. This is diagram. Another question. Consider the following data points of these equations using the Lagrange and Newton interpolation method. Estimated the value of the function at x minus of 9. For choose the interpolation method, perform the following tasks. Task. Given data 5, we can use the Lagrange interpolation to estimate f of 9. The plotted graph. This is plotted graph. Uh, Given data in red, Lagrange interpolation estimated this error explanation exact function unknown, so no actual value of f of 9 to be compared, but the interpolation is smooth but and 9 is within the range of known value and low error likely. Relative error if actually available, the relative error is equal to if actually minus of f of 9 by f of actual. So this is find out the formula for relative error. Question number 3. You are given the following set of data points. This, using suitable numerical differentiation technique, estimate the first and second derivative of function of x. This is the condition of describe the algo and flowchart interpolation the present intermediate result. So the first of all algo start. Input the points x of 0, y of 0, x1, y1, xn, construct construct the Newton divided differential table, calculation the first divided differential. This keep building the higher divided differential. Differentiation of p of x symbolic or term by the term. Evaluation the first and second derivatives. PSI at a external output the result end of the algo. Data points. So this is data points and value of f of x is 151 this. The f of 9 belongs something nearly belongs to 320.16 and double differentiation is 68.67. Error estimate. The error depend on the higher order derivative of the true function. Since we don't know the actual function, we can't compute the exact error but can estimate the error is equal to this. Fourth question. Obtain the formula for numerical quadration and obtain the Simon's rule. Write the algorithm rule. First, numerical quadration. Numerical quadration refer to approximately defined integral by the evaluation of the function at a specific point and weighting this value. General quadration. This formula for general quadration formula, where the x of I are sample points of interval and w of I weight assignment to the each point and its number of point to use. Uh, deriva- Derivation of Simon's 1 by 3 rules from quadrature. The derived Simon's will be approximate the function f of x by the second degree polynomial over the interval. Divide the interval into two equal parts, given 3. This using Lagrange integration for the quadrature polynomial and integrating the integral interpolative polynomial is this. It's called Simon 1 by 3 rule. I'll go with the start input of f of x, compute the step minus 1 is the initialize total entry integral I is equal to 0 for each group of sub interval. Compute this x0 is equal to that, x1 is equal to x naught plus h, and x6 is equal to h is x naught plus 6h. Evaluation this. X0 is equal to f of 0 and f1 is equal to x of 1. Compute the partial integral. I of I is equal to 3 of h by 10 in the bracket of f naught plus 5 of f1 plus f2 plus 6 of f3 f4 f5 f6. Add to the total. I is equal to I plus this. Repeat the for all intervals. Print the final integral of I value and the Fidel's formula of the interval is divided into the six sub intervals for width of h. This is the formula for that. This is this, this is formula. The fifth question is write the algorithm computation Gaussian quadration formula for n is equal to 5 and evaluation this is the algorithm is start input the function of f of a limit a comma b and convert the integral a comma b to the n comma n using the change of variable. This is the formula of that. For the n is equal to 5, we use the standard node x of y and weight the I. Compute this. हमने calculate किया this equation को and output of the value I and print them and end of the algorithm. Given this equation, limit goes to 0 to 1 and dy by 1 plus x square. Let f of x is equal to 1 by x square. We convert the limit to x minus of x to x using the change of variable explained using the Gaussian quadration formula. X is nearly about this. Relation using above formula final result approximately I is nearly about 0.7853, which is nearly about pi values 4.3 something. I will this. Applying poverty and solve given system of linear equation using any directional method. This is all equation. This is matrix, and the largest column of the row is. So going to that, make the element below the pivot in R2 is equal to 0 and multiplier for the R2 is 1 by 3. This is equation. R2 is equal to R2 minus of this 1 by 3 of R1, which cause this 0.04 by 3, 8 by 3, and 32 by 3. Make the element below the pivot R3 is equal to multiply the 4 R3 into 2 by 3. So R3 is equal to R3 minus of 1 by 3 of into R2. So the value is 0. The final matrix is this. Uh, Multiplier 4 by 3 by 5 by 3. So 4 by 5. So another R3 is equal to R3 minus 4 by 5 into R3, R2. Compute second element 4 by 3 minus of 4 by 5 into 5 by 3. This is equation to 0. Third element is 8 by 5 and RH is equal to 8 by 5. This is and the new matrix. This become this uh, from the row 3. 8 by 5 z is equal to z. So z is equal to 1. Equal to 8 by 5. So z is equal to 1. For second row. 5 by 3 y plus 4 by 3 into 1 is equal to 34 by 3. So the equation is equal y is equal to 2. For row 1, this is 3x plus 4 plus 1 is equal to 10 by 3. So this is the value is this x is equal to 1. Is finding the x is equal to 1 and y is equal to 2 and z is equal to 1. The question number 7, write a algo for the best iterative methods on the below given equation output from question Jacobi method and Gaussian-Seidel method. The Gaussian-Seidel method given a system. This is a given a system a of 1 x plus b of 1 y plus c of 1 z d1 a2 plus b2 y plus c2 z is equal to d2 and a3 x plus b3y plus c3 d is rearranging the equation solve and this is equation and initializing the Gaussian x0 y0 and z0 for all repeat and an iteration until the error less than tolerance. This is stop when x is x are below the tolerance. Okay. Iteration. Initialize the Gaussian x naught is equal to y naught is equal to z naught is equal to 0. We all do three iteration. Iteration 1. So iteration 1 x1 is equal to 14 minus of 0 into 2 minus of 3 into 0 is equal to 14. Y1 is equal to 1 by 2 bracket of 10 minus 3 into 14. So the value is this minus 15. Z1 is equal to 1 by 2 bracket of 14 minus of 2 into 14 minus of 3 into 15 bracket is equal to 10. The iteration 2 x2 is equal to value of this is 16 and x and y2 is value 1 by 2 into bracket of 10 minus 48 minus of 10 which is value is 20 negative 424 and y2 is equal to negative 20 is a Gaussian is not good choice here because system is dry, diverging. Try Jacobi method instead of Gaussian system method. Gaussian Seidel divergence. Well, use the same initializing x and y not zero, z not is equal to 0. This is equation. This is equation at all. Iteration 1. X1 is equal to 14, y1 is equal to 5, z1 is equal to 7, iteration 2, y2 is equal to minus 17, y2 is equal to x2 is equal to minus 217, y2 is equal to minus of 19.5, and z2 is equal to minus 14. Jacobi method is also diverging. This system is not suitable for iterative method due to lack of diagnosis diagram. Last 8 questions. Write an algorithm for Ranger-Kutta method and given the output in ordinal equation. This is equation. So algorithm start. First of all, start. Define the definition. Definition this. Input the initialized condition. X is equal to 0, y is equal to 1, and step the size is x is equal to 0.5 to 5. Find the value of f of x is equal to 1. Repeat the following step until x is greater than f of x. Compute k is equal to 1 h into f of n as x and y n. K is equal to h into f of this this equation. K3 is equal to h into f bracket of x of n plus h by 2 into x of n plus k2 by 2. K4 is equal to h into f of f xn plus h y and n plus k3. Update is equal to x of n plus 1 by 6 plus k1 plus k2 plus k3 plus k4. Update x of n is equal to x n plus h. Output y is at the each step and end of algorithm. So this f of x y comma x, and find the value of 1 plus x plus y, and x naught is equal to 0 and y naught is equal to 1. H is equal to 0.25. Find the value of y is equal to 1. Y is equal to 1. We calculate x is equal to 0.25, 0.5, 0.75 and 1. Uh, the step is x is equal to 0, y is equal to 1, and the f 0 comma 1 is equal to 1 plus 0 plus 1 plus is equal to k is equal to 0.25 into 2, this is zero point 0.5. The f of this equation, this becomes 0.5937, and f of this equation is equal to become 0.605487. F of 0.25 plus 1 of 1 plus 0.6 plus 0.713. y1 y1 is equal to 1.60205. Step 2 of x is equal to 0.25, y is equal to 1.6020. The K1 is equal K1 value is 0.7130127. K2 value is become 0.833389. K3 value is 0.848436. K4 value is 0.9676, and Y2 value become 2.64461. Step 3 is x equals 0.5, y equals 2.44. K1 is 0.9865, K2 is 1.169884, K3 is 1.204996, and K4 is 1.2907. And Y3 becomes nearly about 3.6217. Step 4 is y is equal x is equal to 0.75, y is equal to 3.617. K1 is equal to 1.568, and K2 is equal to 1.868, and K3 is equal to 1.905, and K4 is equal to 2.265. Okay, and Y4 is equal to nearly about 5.25, but final answer is y1 is equal to 5.2555. This is the answer. Thank you for watching this video. Thanks a lot. Bye.